So what I want to talk about in this lesson is a diagram that we can use to look at and study stars in a little bit more detail. I'll just write down the name of this diagram. Hurston-Russell diagram. So if we were to look at this diagram, kind of have an idea of what's going on with it. So it kind of looks something like this. Let me just write a simple diagram. Imagine we have a diagram, something like this, and you have, let's say, hot. So this so hot and cool, and then you have less luminous, and then more luminous. So what we can do is we can look at the luminosity of stars, and we can place them on this this diagram here. So the way that it kind of, so what we have is we kind of have something that goes like this. So just very roughly. So if we were to take the sun for example, the sun would be somewhere here, let's say on this diagram. So the sun, this would be our sun. And what we have here is we have like, so this line here, and these are, it's called the main sequence. And within this, so like if we were to place, we can place stars all along this main sequence here. So it depends on like how hot the star is burning, and then how much light or how luminous it is. So the star, our sun, will be somewhere roughly around here on this what's called the main sequence. And what you have here is you have, in this particular star, you have helium being fused into hydrogen. Sorry, hydrogen being fused into helium. So what you'll have is you'll have a core. You'll have a core here. So you'll have a core of helium being formed. So imagine this is your star, and then out here you're going to have hydrogen. So what's happening is hydrogen is being fused into helium here. So hydrogen to helium. And this here will be known as a main sequential star. So a way to kind of think about this is that you have, even maybe not so much like this, probably put it something like this. So you could say that what you have is you have this hydrogen core, and what's happening is it's converting hydrogen into helium, and it's making this, like, let's say, a helium core inside here, like so. So it'll start off a small, very, very small helium core, but it'll be mainly hydrogen that's within the core. And what happens is once the star is burning helium along here, and it can burn helium for a long, long time. So you could say 90% of the fusion that's going on is this fusion here. So this is a fusion reaction. So hydrogen is being compressed into helium, and you're getting a lot of energy being given off. So it'll kind of start here, and as it continues to go through this fusion process, it'll get hotter and hotter and brighter and brighter, and then it'll come to somewhere around here. So what happens here is you have So in around here, you're going to have a helium. You're going to have a helium core. So imagine, so we end up with a core that's helium, and then around here we're going to have hydrogen that's also being, so that this hydrogen continues to get converted into helium, and this core here in the middle continues to grow. Imagine this is the star here. So let's say, so imagine this is your, so this is your main sequence, and then when it gets to here, you get this kind of process starting to happen. And what will start to happen is it'll continue to grow. It'll continue to grow like so. So in this, so from, let's say from here to here, what's happening is you're getting helium is being, helium then starts to get fused. Now what will happen is this will continue to happen. So while this star has hydrogen to burn, it'll stay, let's say, within this sequence here. But what will start to happen is eventually what's going to happen is this hydrogen is going to run out. So you're going to end up with just this helium core. And what will happen is it'll actually, the star will start to spread out. It'll actually start to expand. So it starts to expand. And this is what's known as, these are what, once it kind of gets up to this stage here, these are what are known as red giants. So this is a red giant. So what's going to happen then within this red giant, it's going to start to fuse helium. So you're going to get helium being converted into carbon. So you're going to get, so it'll start to move like this, it'll start to go across this way, so it'll start to get very hot. Its luminosity might just kind of dip a little bit, but it'll continue going this way until it gets to this stage here. And here we're going to have a carbon core. So imagine this is your helium, so helium is getting converted into carbon. So what's going to happen, you're going to start off with a small carbon core, and eventually that's going to get much bigger. So we'll draw this down here. So you're going to have, imagine you have a carbon core, and then around here you're going to have helium, and then you have this star around here like so. So this will continue on until you get this carbon core. And eventually what's going to start to happen is carbon is going to start to get fused as well, and then it's going to move in this direction here. So in this direction here, you're going to get iron. Iron is going to be produced. So this is what's known as later burning. So later burning stage. And this is going to eventually end with a star that's going to have an iron core. So imagine this is a carbon core. So this is a helium core. So you're eventually going to get up to this stage here where you're going to have an iron core. So this will eventually continue to burn until you get this, until you get this iron core. So it's going to have an iron core. Imagine this is your star here. Now, what will happen is along this, as we get to this process here, so if we zoom out a little bit, what you're going to end up with is you're going to end up with an iron core. So let's say Fe. So this is your iron core. Then outside this, you might have other elements such as let's say sulfur, and maybe carbon. And then outside this, you're going to have, so it's like a layer, it's like an onion. You might have oxygen, for example, and silicon. Then outside here, you're going to have, let's say, carbon. And outside here, you're going to have helium. And then outside here, you're going to have hydrogen. So imagine like when it gets up here to this stage, you're going to kind of have a star that looks something like this. It's going to have an iron core. And what's going to happen is it's actually going to explode. It'll explode. But when it explodes, all of these layers of elements here that have been generated through the process of fusion, they're all going to be released into the environment. So imagine this all gets released into the environment, and then you're going to have this big gas cloud that's going to be enriched with all of these different elements, let's say within it. You're going to have all these different elements that have been produced, these heavier elements that are going to be produced. And what will happen is they'll start to come together and they'll start to form other structures, let's say, within the system that it's in. Now what we can actually do is we can use this this diagram here, and we can look at stars. So we can actually look at the luminosity, like the color of them, how bright they are, and we can classify them, and we can put them, let's say, somewhere within this diagram. We can also look at how hot or cool the stars are burning. So as you can see here, so like let's say this main sequential star, so when it's, let's say when it's kind of here in this stage here, it's actually burning quite hot in comparison to when it gets to this stage, when it turns into a red giant. It actually cools down significantly, so it does. And then as this then starts to change and fusion starts to happen here, it starts to heat up again and it starts to get hotter. But as you can see, the luminosity and the heat, for example, changes as we start to go through this process. So we can use these diagrams, for example, to kind of place stars along this diagram and start to kind of study them. And what we can do, we can tell by its luminosity and the heat, for example, the processes that are going on, let's say, within the core, and the elements that you have present within the core as well. So that's kind of the basis behind this Hertzsprung-Russell diagram. So hopefully that makes sense, and thank you for listening.